This GCSE foundation topic is going to look at conversion graphs. People tend to find this quite a tricky topic, and it does come up quite a lot, so it is definitely one that's worth getting the hang of. Now, what a conversion graph is it plots one variable against another. So this one says, at sea, the distance travelled by ships is measured in nautical miles rather than miles. The table below shows the number of miles and the number of nautical miles for each of the three distances. Okay, so this is basically, it compares how many miles there are to how many nautical miles. Okay, and on our y-axis, we've got the nautical miles, and on our x-axis, we've got the miles. Okay, now part A is to plot the coordinates and then to obviously draw the conversion graph. Okay, so if we have a look, step one, plot coordinates. So all you're going to do is you're going to go onto your graph and you're going to plot each of them coordinates. Okay, so you're going to have 3 coordinates hopefully by the time you finish it. Now you need to be careful of how you plot them. Obviously you should be able to read the scale. It's going up in 2s in 5 squares, so every 2.5 squares you go up, or basically in the middle of the 2 numbers, is worth the 1. Okay, so it's not that complicated scale. You need to be careful. I would advise you use a ruler as well. Once you've found one of them, so if it's 8 miles, put your ruler on 8, go up, and then find 7, and then you should lie alongside your ruler somewhere. So first one, all I'm going to do is I'm going to plot it. They are my 3 points, and I've just ticked them off as I've gone. You should notice they roughly lie in a sort of diagonal line. Okay, they shouldn't be dotted all over the place. They should roughly lie in a line. Point 2 then, that's worth 1 mark by the way, just plotting the coordinates correctly. Step 2, straight line through coordinates and point 0, 0. Okay, the reason why you can go through the point 0, 0 is because if you think about it, 0 miles would also be 0 nautical miles. Okay, 0 of something is going to be 0 of the other thing. Okay, so you can also plot that point to help you. So I'm going to plot that first of all with my blue pen there, and then I'm going to draw a straight line that connects all of them points. Now this is important. It doesn't just go from the blue dot to the first red dot, or from the blue dot to the second red dot, or even to the third one. It goes all the way through the graph paper, okay? So for every little square on that graph paper, there should be a line cutting through, okay? So it should look something like that. You can even extend it further on if you want, just to make sure you've done it. If you stop short, you will actually be deducting a mark, okay? So draw the line all the way through. Right, I can see that I'm right, basically. It's because my points all lie on that straight line. Okay, if one was, say, a bit off, then I probably should go back and check that one. Okay, so they all lie on that straight line. That will give me my second mark. Okay, so that's my 2 marks, my plotting. That now is my conversion graph. Okay, so that's going to help me for part B. Part B is slightly more tricky. Step 3, use your conversion graph to find one variable from another. So for us, it's finding how many miles 50 nautical miles is worth. So I've highlighted the 50 nautical miles. That's the bit we're given. So that's what we need to find. We're going to draw lines across from there. But if you look at number 4, there is actually a problem. If our graph went up to 50 nautical miles on the y-axis, it would be fine. We just draw a straight line across, and where it hit the line, we draw down and we read off, okay? But there is no 50 nautical miles on there. So what I have to do is I have to find a factor of that 50. So basically, if I find a number which relates nicely to 50, I can find that, and then I can multiply it up to find what 50 would actually be worth. So I put i.e. 5 or 10 or 25, because they are all numbers which go nicely into 50. 25 obviously is going to be out of the question because you can't even go up to 25 on there. So it's either going to be 5 or 10. I'm actually going to find 5 because it works slightly nicer in this example, as I'll show you in a minute. So I'm going to find 5 nautical miles first of all. So I'm going to put a point where 5 nautical miles is. Draw a straight line across, as you can see, onto my red line. Where I hit my red line, I go down, and you can see I'm just less than 6. So I'm going to write that out, and I've shorthanded it. 5 nautical miles equals 5.5 miles, just reading off the x-axis, just less than 6. 50 nautical miles underneath the nautical mile side. That's what I want to find. Right, now I need to look at what the link is between the two numbers for the nautical miles. So we started with 5 nautical miles. We want 50 nautical miles. If you think about it, you need 10 lots of 5 nautical miles to get to 50 nautical miles. So we've times by 10 there. So what do we have to do to the other side? We have to do the same. This is nice and easy to do because 5.5 times in by 10 is quite straightforward, hopefully. Okay, so 5.5 times by 10. Remember, you move the numbers left once or you move the decimal point right once. It's up to you. And you should get 55 miles. Check using your conversion graph, your table more so, sorry, that you are roughly right. You can see, if you look at all the miles and all the nautical miles are always slightly less than the miles. Not much, but slightly less. 1, 2, 3, okay? And you can see here, 50 nautical miles is slightly less than 55 miles. If I had 50 nautical miles was worth 100 miles, I could see that, yeah, I've probably gone wrong because no other measurement that we've had so far is that far between the 2 points, okay? So that's how you do conversion graph. So always remember, even if you can't do part B, plot the coordinates, has to be a straight line. It's always a straight line.